Hi, this is Jafreen, and this recording is related to assessment 3 for FIT 5201, which is related to latent variables and neural networks. Before starting, I would really like to thank you, Borhan and Calvin, for teaching this course and giving us ideas about the algorithm related to machine learning. It was really helpful. So as you know, this assessment has 3 parts, part A, B and C. So I'll go one by one. Part A is related to document clustering, and we were supposed to solve a document clustering problem using unsupervised learning algorithm and had to do soft and hard assignment for expectation maximization. So in our activity, we have done expectation maximization for k-means. Here we had to do this expect EM for document clustering, and so we had to do E step and M step both for soft and hard assignment. So here we had to use word proportion and find out the posterior, which is the probability of the nth document dn being in cluster K. And by word proportion, we mean the frequency or number of times that each word of the dictionary has been seen in the document belonging to each cluster. So in the first part, we import the libraries related to this assessment. Then we initialize some related variable, and then we do the hard and soft clustering and do the EM and E and M step. Okay, so here just reading the task 3a file, the data set, and then did some text processing, and then showing the iteration for soft and hard pose. So and then we perform the PCA for soft clustering and hard clustering. So in the soft clustering, we can see there are 4 classes, and it is showing that there is it's the blue clustering showing pretty well. So let's see the hard clustering. So it's not that much clear, but if we compare with the true level, we can say that soft clustering result was better. Okay, now go to part B. Okay, so in part B, we were supposed to apply a 3-layer neural network and compare its performance with single layer perceptron. So we run here, just running the data set, the CSV file, and plotting to see the data. Okay, and then in the first portion, just running the single layer perceptron, which is related to our model 3.1 activities 3.1. Okay, and just check this test training and test set accuracy. So we can see that perceptron training set accuracy here is 44.08%, and perceptron test set accuracy is 45.12%. And if we plot it, we can see that the test data prediction accuracy, where there are there are a lot of false prediction compared to true prediction. So now we run the 3-layer neural network that we have learned in 5.1 activity. So for this one, we had to run the H2O library. Okay, so reading the data set, Okay, so here we can see that the base choice of K is 7 with a validation set accuracy of 95.88% for 3-layer neural network. And if we see the plotting for the test data, we can see it's much better compared to perceptron. So we see very less false prediction compared to true prediction. So, and now we are plotting this to a table and bowl, making this bowl. So it's showing that for the K numbers for 7K is showing the training error rate is 3.52, and for tester is 4.12, which is definitely better than single layer perceptron. So there is a comparison between single layer and neural network. So what I will say that the key difference compared to the perceptron with neural network is neural network uses continuous non-linearities in the hidden units, whereas the perceptron uses step function non-linearities. This means that the neural network function is differentiable with respect to the network parameters, and this property plays a central role in network training. So that is why in this example, neural network showed better training accuracy and less error rate compared to single layer perceptron. So next we go to self-taught learning. So the data set here is pretty large, so that's why I have actually reduced the data set, and I have reduced the feature size to 249 and row size to 300. Okay, so just reading the label frame, unlabeled frame, the test data. So here we actually had to run the three-layer neural network with 10 units in each hidden layer, and also had to run an autoencoder. So first, in the first section, I have done the neural network with 3 layers of hidden and 10 units each. So let's see the results. So it's showing classification error without augmented feature, which is 47%. So let's see if it improves when we use the autoencoder. So now we are running the autoencoder, and okay, and see the error here. Okay, let's plot the error here. So if we plot the error, you can see that the error rate is actually scattered for different features here, but it's actually reducing at the end as it increases. And now we try to find out the optimum unit in the middle layer of the encoder in terms of reconstruction and misclassification error. So if we plot it, if we print it, we'll see that number 5 is the optimum number for the reconstruction error, where we can see least error somewhere here, and for the misclassification it is 293, feature number 293. That means K equals to 43. Sorry, it should be 293. I'll fix it before uploading this one. Okay, so what I can see is that in terms of the autoencoder reconstruction error from the plotting, we can say that it increases at K increases, and we can get the optimum feature for the misclassification error for the feature 293. So I think that's it for the time being, and thank you again. Thank you for listening.